To our PowerSchool Learning page. I will try to upload this video onto PowerSchool Learning as soon as I can. I'm not sure how it's working right now. It wasn't working very well yesterday or this morning, but I'll do the best I can. I actually made this video yesterday, but unfortunately the sound didn't upload to YouTube. So I am going to make it again, and this is going to be a review for your assessment that starts tomorrow, Friday the 20th. So today is Thursday the 19th. So all you have to do today is watch these videos and then do some review problems on your own. So this is the practice sheet that I'm going to be giving you guys. So it looks like this, and there's also some other practice problems and the answers to the practice problems. So you will have no shortage of practice when you are studying for your assessment. Okay, so I'm just going to start on this one for now. I can zoom in a little bit more. All right, so let's see. So your assessment is going to include balancing chemical equations, which is what this video is about, and it's also going to include predicting and identifying single displacement and double displacement reactions. So today I'm going to have you work on balancing chemical equations and single displacement reactions, and then tomorrow you will work on double displacement reactions. So what I'm going to do is go through a couple of practice problems so that you can see what is expected of you, and then we can kind of just go from there. Remember, if you have any questions, please just feel free to reach out to me through my email at any time, and I will answer any questions that you have. So remember, the reason why we want to balance chemical equations is because we want an equal amount of atoms on both sides of this arrow right here. Okay, so no, I don't want any of it. Sorry, I'm doing this on my computer, not my iPad, so it's a little confusing. So I want to make sure there's an even amount of atoms on both sides. So you might remember this from the law of conservation of mass lab. Mass cannot be created or destroyed. So we want to make sure a chemical equation is balanced because that shows us that we have not created or destroyed matter and that it stays exactly the same. Okay? So remember the way that I like to do this, we've done this in class a few times, is first kind of writing, hang on, this is going to be a bit of an adjustment for me. Let me see if I can figure something out so that it's not so complicated. Bear with me, please. Nope. This is what I do. Oh no, that's a highlight. Well, I'll try the best I can. Nope. So we have iron in this equation, and then we also have chlorine. So all you have to do is kind of list the types of atoms that you have. So in this case, we have iron and chlorine, all right? So first thing I'm going to do is count to see how many atoms are on each side. So if I look on the left side of this arrow right here, I see that there's only one iron atom. Remember, if this were to have a subscript, there would be an invisible one right here. So I'm going to put a 1. And then the same is true on the right side of the equation. There's only one iron atom. On the left side, I see that there's a subscript 2 next to this chlorine, so that means there's 2 chlorine atoms. And on the right side, there are 3 chlorine atoms, just like that, okay? So as we can see, we're not balanced because even though the iron is balanced, the chlorine is not balanced. So what I'm going to do is look to the chlorine to see what is going to be like the lowest common multiple of chlorine. So in this case, I have 2 chlorines on the left, 2 chlorines on the right, or 3 chlorines on the right. What I'm going to do is try to make sure that both of these equal 6 because I believe that is the lowest common multiple. So I'm not very good at math, but I'm pretty sure that's the correct term. Okay, so all I have to do is multiply this side by 3, multiply this side by 2, and then I'm going to take those numbers and plug them in as coefficients right here. So put a 3 right there. Take this one, bring it all the way over here, and now I have a 2 right here. Okay, and now if I recount my atoms right now, I have still 1 iron on this side, and I actually have 2 on this side. So now that I've multiplied these, I need to make sure that the irons are even again. So I'm going to put a 2 right here. All right, so now I have 2 iron atoms, 6 chlorine atoms, 6 chlorine atoms. Remember that this 2 is going to distribute to both the iron and the chlorine, okay? So if you ever have a coefficient like this, it is going to distribute to both of the types of atoms in a compound. So just remember that it does distribute. So that is the first problem I'm going to go over. Let me see if I can get rid of this stuff so that you can have a better sense of what's going on. I originally did this video on my iPad and it was much easier to kind of draw things, but now didn't work on my iPad, so now I'm going to do it on my computer, and clearly this is a little bit more annoying than I originally anticipated, but just bear with me. Doing my best. All right, is there an eraser on here? No. Fantastic. Ooh, maybe I can make it a little bit smaller. Perfect. No eraser? That's a bummer. All right, anyways, back to it. So I'm going to try C right here, because I think this one will be a little bit more hard to balance than letter A. So I'm just going to go over these 2 problems, and then I'm going to upload this problem sheet onto PowerSchool Learning, or also, I've actually already sent this to you, so you can start working on it. It's just the video that needs to be uploaded, okay? So same process as in problem A, is I'm going to list the different types of atoms that I have. So I still have iron, I have bromine, I have hydrogen. Nope, that's not what I wanted. Okay, and remember in this case, if we ever have a polyatomic ion, in this case we do, it's sulfate, we want to keep the polyatomic ion together, okay? So right now we have sulfate, and its formula is SO4. So I'm going to treat sulfate as its kind of own entity. So instead of doing sulfur and oxygen separated, I'm going to do sulfur and oxygen together as sulfate, because that'll make it much easier to balance. And you'll be able to use your polyatomic ion sheet on your assessment, so always be looking for those, because it's much easier to balance an equation when you keep the polyatomic ions together instead of separated, okay? So I'm going to count again, and it looks like I have 1 iron on this side, 2 on this side. Bromine, I'm starting with 3 on the left and 1 on the right. Hydrogen, I am starting with 2 on the left, 1 on the right. Sulfate, I have 1 on the left and 3 on the right. Remember, if I ever want to represent multiple polyatomic ions, I'm always going to add parentheses like that. Why is my mouse being weird? All right, and then a subscript, okay? So if I have an atom like, or have a polyatomic ion like sulfate, and I want more than 1, okay, I'm going to draw my parentheses and then put a subscript for however many I have. So let's say I want 4. I would put a 4 right here. This mouse is wicked sensitive. Okay, so just a quick refresher on that. Delete that really quick. So as you can see, nothing is balanced, so that's fantastic. We're going to try to balance these as best we can. So personally, I would like to start with balancing the sulfate because then I can get 2 atoms out of the way right off. So I'm going to start with balancing the sulfate, but it's kind of up to you with what you want to do. So it's okay if you don't choose to balance with the sulfate, but remember, balancing chemical equations is a lot of guess and check, so it might be frustrating at first, but it's definitely good to kind of be persistent with these problems and just keep working until you find a solution, okay? And we've done a few of these in class, so hopefully you guys feel that you have some experience under your belt. All right, so I'm going to start with balancing the sulfates. So I have 3 on the right side and 1 on the left. So I'm going to try to balance this by adding a 3 right here, okay? So that balances the sulfate because I have 3 over here and 3 over here. Remember, this will distribute to both the hydrogen, and to the sulfate, okay? So I have 3 sulfates, but I now have 6 hydrogen. So remember, if you have a coefficient like this, you're going to multiply it by the subscript to find the total number of atoms, okay? So I have a coefficient of 3 and a subscript of 2 for hydrogen, so I currently have 6 hydrogen. So I'm just going to multiply that by 3. Now we have 6, okay? So if now I want to balance my hydrogen, so that's not balanced anymore, I'm going to go to this left side and right side and put a 6 right here. That was probably the worst 6 in the world, but it's okay. So now I have 6 hydrogen here. 3 sulfate here. All right. Now it's time to balance everything else. So it looks like I have 6 bromine right here because this 6 will distribute to the hydrogen and the bromine. So now I need 6 bromine atoms over here. Right now I only have 3, so I'm going to put a 2 right here. All right. All right. So looking at my equation right now, I'm going to kind of recheck to see if my equation is balanced. And if it is, I can be done. So right now I have 2 iron atoms right here, 2 iron atoms right here. 6 bromine atoms just by multiplying this subscript by the coefficient. 6 bromine atoms right here. 6 hydrogen atoms and also 6 hydrogen atoms over here. And lastly, I have 3 sulfates on the left and 3 on the right. So this equation is balanced, okay? So this would be my final answer, all right? So balancing equations can be tricky and sometimes a little bit tedious. It's a lot of guess and check, but like I said, it does help us better understand the law of conservation of mass because this helps us acknowledge that we didn't create or destroy any mass in this situation, okay? It only changed from iron bromide and what looks like sulfuric acid to iron sulfate and hydrobromic acid, okay? So this has already been sent to you through email since I'm not quite sure about the integrity of PowerSchool Learning. So please take a look at this and please take a look at this video and email me with any questions. So I'm going to follow up right now with the single displacement reactions review, so stay tuned.